Good morning, students. Dear students, as in the previous video, that is chapter 5 laws of motion, part 14, we had discussed about two things regarding the friction. The first thing is about angle of friction, and while discussing angle of friction, we had discussed that when a body is sliding over the rough surface, or when a body is moving over the rough surface, then a horizontal rough surface, then a force of friction, that is the limiting friction, acts on the body opposite to the direction of motion of the object, and the normal reaction acts on the body due to the weight of the body, and the resultant of that limiting friction and the normal reaction, the angle which forms the resultant of the limiting friction and the normal reaction, that angle is called as the angle of friction. After that, we had discussed that the coefficient of limiting friction is equal to tangent of the theta, tangent of the angle, which that resultant makes with the normal reaction. After that, we had solved the numericals based on the angle of friction, and then we had discussed about the topic, that is angle of repose, and the angle of repose is that angle which up to which a surface is inclined such that the object placed over that inclination starts moving over that inclined surface. So that angle up to which a horizontal surface is inclined to the base in such a way that the object placed on the inclination starts moving over the inclined part of the inclined plane, then that angle is called as angle of repose. We will discuss one numerical today on the basis of angle of repose. And now for today's discussion, we will discuss about the another type of external friction, that is kinetic friction. So let us discuss about the kinetic friction. Kinetic friction. I think this is the first type of the friction. First static friction we had discussed, then limiting friction we had discussed, and after that we are going to discuss about the kinetic friction. Kinetic friction. And this kinetic friction is denoted by mu. This kinetic friction is denoted by mu. So, dear students, how can we define the kinetic friction? First of all, understand the concept behind the kinetic friction. Dear students, look at here. If an object is placed over this rough horizontal surface, and a force F is applied on this block, if a force F is applied on this block, then as the force F is applied on this block, suddenly a friction, that is a static friction, starts acting over this object. Now, if this force goes on increasing, then a value comes that is called the limiting friction, that is Us max, when the object just or about to move on this horizontal surface. Now if further this force is increased, if further this applied force is increased, then what will happen? The applied force counterparts the limiting friction Us max, and then the frictional force decreases, that is mu k, and that mu k is the coefficient of friction and it is Fk. Then this friction is called as kinetic friction. This friction is called as kinetic friction. Means the friction developed on the block when the block starts moving. When the block starts moving is called as kinetic friction, and this is the coefficient of kinetic friction. So we will define about the kinetic friction. So we can see that when we increase the applied force, about kinetic friction, when we increase the applied force in such a way that it balances the limiting value of friction Fs max and above which the body starts moving over the rough surface. Means if we increase the force above the Fs max, then the body starts moving over the rough surface, and the frictional force decreases and of constant nature throughout the motion of the object. Now, the value of kinetic friction decreases, it is less than the value of limiting friction, and throughout the motion of the object on the rough horizontal surface, its value is constant. This is about the kinetic friction. Now we will discuss about the formula related to the coefficient of kinetic friction. So let us discuss. So dear students, the force of friction at this stage, is called as kinetic friction or dynamic friction. The force of friction at this stage is called as kinetic friction or dynamic friction. And as we had explained it before, that the value of kinetic friction is less than the value of limiting friction, and the value of kinetic friction UK is less friction. Limiting friction, that is mu s max. Mu s max means the value of kinetic friction is less than, because as we had discussed in the graph also, if it is the applied force, and if it is the frictional force against the applied force, this is the frictional force against the applied force, then there is a linear relationship between the frictional force and the applied force up to certain limit. After that, the body is about to start moving, so it increases up to certain value and then decreases and becomes constant. So this is the case of static friction. This is the case of mu s max. That is the limiting friction, and this is the case of mu when motion starts. Now from this graph, I hope you have cleared your concept regarding all these type of friction, that is Fs max and F. Now we are going to discuss about the laws of limiting friction, the laws of kinetic friction. So dear students, the first law of kinetic friction says that the kinetic friction always opposes the relative motion of the object and the surface, and its value is constant throughout the motion of the object on this surface. So kinetic friction always opposes the motion of the object over the surface, and its value is constant. Throughout the motion of the object. The second thing is, this is the first law. No need to further explanation, just look at here. If the object is moving with velocity v over this surface, then a kinetic friction, since the motion has started and the body is moving over this surface, so a opposing frictional force, that is kinetic friction, Fk, always acts between the surface and the object, which opposes the motion of the block over this rough surface. So this is called as the kinetic friction, and its value is constant throughout the motion of the object over the horizontal surface. Its value is fixed. Now the second discussion is kinetic friction. Kinetic friction does not depend upon the area of contact between the object and the area of contact between the object and the surface until the normal reaction, that is normal reaction, that is R, remains the same. Remains the same. It means to say that in case of static friction also I had explained this. Okay, if static friction, when we are discussing about the coefficient of limiting friction or static friction, in that case also we had discussed that if the area of contact is changing but normal reaction is not changing, then the value of limiting friction or static friction does not changes, because it depends upon the normal reaction. Means to say that suppose there is the object and this is the area of contact. If the area of contact is increased or decreased but the normal reaction remains the same, then in that case the Fs max or Fk always remains the same. So this is the second law, and the third law is that kinetic friction does not depend upon the velocity of the object on the surface. Kinetic friction does not depends upon velocity. Okay students, if on this rough surface, if an object is moving with, suppose the velocity is 3 meters per second and the same object is moving with 5 meters per second, so kinetic friction does not depend upon the velocity. The 3 meter, 5 meter or 7 meter does not depend upon it. The frictional force remains the same unless the normal reaction is not going to be varied. If the weight of the object is going to be changed, then the frictional force also changes. So now the last point is the value of mu k. Last point we will discuss about the value of mu k or coefficient of kinetic friction. Now dear students, the fourth point, the fourth law is, as we have discussed before also and in previous points also, that normal reaction, the kinetic friction is directly proportional to the normal reaction. Kinetic friction is directly, means if the normal reaction increases, then kinetic friction increases. If the normal reaction decreases, then kinetic friction decreases. Now we can write here that replacing this constant of proportionality with equal to sign, then we have to put a constant over here, and this is mu k r, and from here we can write the coefficient of kinetic friction mu k is equal to Fk upon r, that is kinetic friction upon normal kinetic friction upon normal reaction. So as we have discussed, we will discuss about relation between mu k and mu s max. Now, as you know that the value of kinetic friction, Fk is less than Fs max. Value of kinetic friction Fk is less than Fs max. We had discussed before graphically also, and with example also we had discussed this thing. Now we can write here as, if we are talking for the same object, for same object, because if the normal reaction changes, then the friction also normal reaction changes, the Fk and Fs values also changes for the object. So we are keeping the same object over which the kinetic friction and limiting friction is acting. So we can write Fk as mu k into R, mu k into R is less than mu s max into R. Now this will cancel out, and we can say that mu k is less than mu s max. And from here we can write that coefficient of kinetic friction is less than coefficient of limiting value So this is the relation between mu k and mu s, and this is similar. This formula is similar as we had discussed in the static friction, or we had discussed in the limiting value of friction. The similar formula is here. So dear student, these things we had discussed about the kinetic friction, and you have to study that much only about the kinetic friction. Now we are going to solve two numericals. First numerical is based on the angle of repose, as well as the kinetic friction is also included in that numerical, and the second numerical based on the kinetic friction. The two numericals we are going to solve. Now dear students, look at the numerical. You can say that this numerical is based on the angle of repose as well as the kinetic friction, because here the mass M is moving on a plane inclined at an angle of 60. Since it is moving, not static, since it is moving, so here angle of repose is there, and the friction which acts on the object is the kinetic friction. So we have to find out the coefficient of kinetic friction. So dear students, let us draw the diagram related to this. A block of mass M, this is the inclined plane, this is the inclined plane, and over this inclined plane a block of mass M is kept over this inclined plane, and this inclined plane, suppose here angle is 60 degree given, but we are putting here theta, and when we will discuss in the formula, then we will put the value of theta, that is 60. So this is the angle theta. With this angle the surface is inclined with the horizontal, and acceleration is given, that is g by 2. So we have to find the value of kinetic friction. So dear students, look at here. This is the weight mg, and the normal reaction acts in this direction, the normal reaction R acts in this direction, and since the block is moving in this direction, then the kinetic friction Fk is acting in this direction. Now this angle is theta, so with vertical it is also making an angle of theta. So mg is making theta with the normal direction, because suppose this surface is in this direction, then there is no angle theta, but as the surface is inclined with an angle of theta, then the normal reaction makes an angle of theta with the weight mg. So this component, resolving this mg into its two components, so this component becomes mg cos theta, and this component becomes mg sin theta. So look at here, students. The block is sliding in this direction, and this is the vertical direction. So resolving the forces, we will get along x-axis. First of all, we will along, suppose I am drawing this. This is x and this is y. This axis is y and this is x. So suppose this axis is x. So we are taking along x axis, along x axis. So along x axis, mg sin theta, mg sin theta minus Fk is equal to ma. Clear, students? Now here, acceleration of the block is given as g by 2. Since a is equal to g by 2 is given in the question, so we can write it as mg sin theta minus Fk is equal to mg by 2. Now putting the value and calculate the value of Fk. M mass is given, theta is given, so putting the value of theta, first of all, Fk is equal to mg sin theta minus mg by 2, and from here we can write it as Fk is equal to mg sin 60 degree minus mg by 2, and you know that root 3 by 2, mg root 3 by 2 minus mg by 2, and taking mg common, we will get root 3 minus 1 divided by 2. This is the value of Fk. This is the value of Fk. This is the value of Fk for the motion along x-axis. Now we will discuss about the motion along y-axis. Motion along y-axis. For motion along y-axis. For motion along y-axis. So for motion along y-axis, we do what R is equal to normal reaction is equal to mg cos 60 degree, and R is equal to mg by r is equal to mg by 2. Now we know the relation. Now dear students, we know the relation Fk is equal to mu k into r. This is the relation, and from this relation we can find mu k is equal to Fk upon r. So the Fk, the value of Fk you had calculated, that is mg root 3 minus 1 divided by 2 upon r, that is equal to mg divided by 2. Mg to mg cancel out, and it will be equal to root 3 minus 1 divided by 2, and it is equal to 2 upon 1, so to cancel, and so the value of mu k is equal to root 3 minus 1. So this is the value of coefficient of kinetic friction, that is mu k is equal to root 3 minus 1. That is the coefficient of kinetic friction. So this is a good question, students, which is a combination of the angle of repose as well as the kinetic friction. Now one another question we are going to discuss. So dear students, this is a good question, and look at this question. Here you have to find the value of acceleration A, which is produced due to the pulling in the blocks. You have to find the acceleration A, and the second thing, you have to find the tension produced, the tension T produced. So since the weight is in this direction, so tension T is acting here, and to counterbalance this tension T, the tension T in this string is along this direction. So in such a way, the total tension is T in this direction, and T in this direction going to counterbalance. Net tension is equal to 0. So tension in this direction, and another force, that is Fk, is acting in this direction. So we have to find the value of acceleration A. So first of all, we will write the equation for this. Since the body is accelerating in this direction, so we have to find the acceleration. So we have to minus t 30 minus t is equal to 3a. This is equation number 1, and since the body is accelerating in this direction, so we can write it as t minus Fk is equal to 20 into a. This is equation 2. But in the question, the value of mu k is given, value of Fk is not given. So we find the value of Fk for here. Fk is equal to mu k into r, as you had studied. And normal reaction for this is we have to consider G is equal to 10. So this value is 0.04 into 20 into 10, and I think 2200 for 8, so it will be 8 Newton. So Fk will be 8 Newton. Now we can put the value of Fk here. So T minus 8 is equal to 28. This is equation number 3. Now if we add the 20a. If we add equation 3 and 1, on adding 1 and 3, look at here, 30 minus t is equal to 3a and t minus 8 is equal to 28. So t cancel out and it will be equal to 22 is equal to 23a and a is equal to 22 upon 23. It is equal to 22 upon 23, that is 0.96 meter per second. 0.96 meter per second square. So dear student, very easily we have calculated the value of acceleration produced in the mass pulling system. Now in any of the equation, either in equation 3rd or in equation 1st, you can put the value of a and get the answer. So 30 minus t, putting a in equation first, so 30 minus t is equal to 3 into 0.96 meter per second square, and it is equal to t is equal to 30 minus 3 into 0.96 meter per Newton, and it is equal to 30 minus 3.98, and the value of t will be 27.12 Newton. That is equal to 27.12. So t is equal to 27.12 Newton. 2.88. It is equal to 2.88. So the value of tension T is equal to 27.12 Newton. So dear students, this is all about today's video, and we had discussed various numericals based on the angle of friction, angle of repose, kinetic friction, sliding friction, static friction, limiting value of friction. Now in the next video we will discuss about various type of kinetic friction, that is sliding friction, rolling friction. Little bit we will discuss about sliding friction and rolling friction, and then we will discuss about the various ways to reduce friction for the moving body. So all these things we will discuss in the next video. So that's all for today, students. Have a nice day.